a probability question. We have a sender S and a receiver R which are following a transmission using two different types of signals H and L. A sender can send either of these two signals to the receiver and receiver will interpret what it has received. Now the probability of the sender sending a signal H is 0.1 and sending L is 0.9. So let us note down these probabilities. Probability of sending H. S means sender, the signal has been sent, and which signal was sent? H. So this probability is 0.1 and probability of sending L is 0.9. Next, in the graph below, the weight of an edge u, v is the probability of receiving v when u is transmitted, and both these uv belong to H and L set. So now let us consider this H. It's our sender side and the receiver side. HL, two types of signal which it can send, HL which it can receive. Now, as we can see in this graph, it is possible for the receiver to misinterpret a signal. When H was sent, it can receive H, it can also receive L, which means it can misinterpret the received signal to be H or L, irrespective of what it originally was. The probabilities of happening such things are given in this graph. So now if we consider this particular edge, this edge. Now this is edge u, v, and what it is said, the edge u, v represents the probability of receiving v when u is transmitted, means probability of receiving L when H was transmitted. This is what that edge is representing, and probability is given as the weight of that edge, which is 0.7. Similarly, the other edges, this one is probability of receiving H when L was sent. It's 0.8. For this one, probability of receiving H given that sent was also H, it is 0.3. The last one, probability of receiving L given that L was sent, is point. This one we are dealing with LL 0.3. So that is all the information given to us. And now what is asked to us is, if the received signal is H, which means probability of, let us read it completely, the probability that the transmitted signal was H. We have to find out the probability that the transmitted or the sent signal was H, given that the received is H. It is given that H has been received. Then what is the probability that H itself was sent? Isn't it 0.3? Simply looking at this branch. No, it's not. This branch is representing the probability that H was received given that H was sent. This is the reverse of that. We want probability that H was sent given that H was received. So both are different, but they are closely related. We can derive one from the other. How do we do that? We can write this one as, using the Bayes theorem, can write it as probability of sent H intersection received H upon probability of receiving H, and we can further simplify it as, the numerator is, it can be written as probability of receiving H given that sent was H multiplied by probability of, now as we know, we can write an event as, let us say, probability of A intersection B, it can be this one divided by probability of B is equivalent to probability of A given B. So if we want this intersection, then we can write it this way. The numerator can be written as this, receiving H given that sent was H multiplied by probability of sending H, upon the denominator is probability of receiving H. So now we have to calculate this thing. And how do we do that? This value we already know, it is 0.3. What is the probability of sending H? 0.1 from here. Now we want this one, probability of receiving H. We don't know that already, so we'll also have to compute it. And how do we do that? And there are two cases in which we can receive H. It will be probability of receiving H given that H itself was sent, and probability of receiving H given that L was sent. So that can be written as, it will be probability of receiving H given that H itself was sent, and this will be multiplied with probability of. Now we are using the Bayes theorem to divide this into two different cases. For receiving H, there are two cases. Here we are dealing with the first one, receiving H given that H itself was sent. So here we will have it this way, means we sent H, and then given that we sent H, what is the probability that we'll receive H? Same way the second case would be probability of receiving H given that L was sent, multiplied with probability of sending L. So here we sent L, and then probability of receiving H given that L was sent. So this is what will give us the denominator value. Let us calculate it. This we already know is 0.3. Sending H is 0.1 plus of this also we already know, it is 0.8, and for sending L it is 0.9. So we calculate that. Let us do it on this side. Yeah, on the left we have some space. So this will be 0.03 plus 0.72 equal to 0.75. So this is our denominator. And what about the numerator? It is 0.3 into 0.1, which is 0.03. So we compute this. The numerator 0.03, denominator is 0.75. So removing the decimal point, it becomes 3/75. You can cancel it out to get 3 twice 6 and 3 5s 15. So it is 1/25. But we want it rounded off to two decimal places. So this will become 0. We take 1 0, not divisible, 0, one more 0, 4, 25 4s 100. So we get the result as 0.04. It was a conditional probability question using Bayes theorem. We have solved it, and answer we got is 0.04.